Gude! Some time ago, I have chatted with a really nice and active guy from Microsoft AI community called Jarvis. Shout out to you, Jarvis. And he watches every of my videos, so thank you for that. And he told me that he likes that type of video where I am talking about issues I've run into and the way I solve these issues or get around them. So hopefully that is a video of that type, not just for you, Jarvis, but for more of you. And so what is it about? As probably some or the most of you know, I am currently in the process of re-recording my Thorsten neutral dataset. And why? Because I made mistakes on the first version. So I used a bad microphone and recording setup, and I've spoken very clear each word, but the naturalness of the flow, of the speech flow, got lost. So I have decided to make a new neutral dataset without these issues. So better microphone setup and a more natural speech flow. And after I have recorded around 3,000 phrases, I shared some samples to community members and friends and asked them, what do you think on the quality and on the naturalness? And I received the feedback that it could be a little bit too fast. And the breaks between each word sometimes could not be recognized. And I thought, okay, that's a good feedback. So thank you for the feedback. And I recorded the next phrase a little slower. Still hopefully natural, but slower. And now, after having 8,000 recordings done, I made a small Glow TTS training to get an idea if the speech flow and the understandable or the understandability is good. So I made a short training and I really found it's too fast. And honestly, if I have problems understanding my own synthesized voice, even if I'm used to my voice, that would be a problem for other people understanding it, to understand it. So I have thought, what can I do? I have to identify the fastest recordings and probably remove them from the data set so that the model will not learn to speak too fast. And even if I'm really far away from having a closer understanding how that machine learning technology is working in detail, I understand one really important thing. The quality of data you put into that machine learning magical black box will be the indicator of the quality of the model that is trained. So if you put in bad recordings, bad audio recordings, you will receive a model that is synthesizing bad audio. If you put in speech that is too slow, too fast, too unnatural, you will receive a model sounding too slow, too fast, too unnatural. So to make it even shorter, shit in, shit out. That's it. So what I have done to identify my files that I've read or recorded a little bit too fast, I've made a little Python script and have uploaded it already to my GitHub repository. So that is what today's video is about. I will show you that Python script on how to identify files that have been spoken too fast or too slow, and based on an LJ speech file and directory structure based dataset. So that's it for the intro. Let's go into it. Is to open the web browser and go to GitHub, Thorsten Müller, Deep Learning German TTS. That's my repo. And jump to the subfolder helper scripts. And here is a new one called Get Dataset Speech Rate Python. Let's open that one up in raw and just save it. It's up to you if you clone it or if you download it the way I am doing it right now. Save it to your local disk and close it. So let's take a look to that folder. What I've prepared earlier is I've copied my Thorsten neutral data set from my currently re-recording session here in that YouTube directory in the documents folder. It's the classical LJ speech directory syntax with metadata CSV file and a WAFs subdirectory. So let's open that new Python script with an editor. So it's a really simple script. I have to adjust the path to the data set. So in that case, it's should be documents, YouTube, neutral. What it will do, hopefully, is it will open the metadata file and the WAFs files within that dataset directory and create a new CSV file with the file name, the audio length of the specific recorded file, the number of characters taken from the metadata CSV file, will do high complex mathematics, no, just will divide the length with the audio duration, and will add a default parameter with remove from dataset, which I will explain later on. So, as you can see, it's a simple, less than 40 lines of code, simple script. Let's open it in a terminal. Documents, YouTube. So we have it here. And let's try executing it with Python 3. Yep. Take some time. No output is a good one. So let's check the directory structure again. We now have in that dataset directory, in addition to the metadata CSV file, we have a speech rate report CSV. I know, no really creativity name, but it's doing its job. So, and let's open that CSV file with an Office document browser. It's split by a semicolon or colon. So let's open it that way. What we have here is that simple structure. First column is just the file name. The second one is the audio length in second, or that specific recording, the number of characters spoken in that phrase, and calculated the characters per second, which is obviously the speech speed. The remove from dataset, let's discuss this a little bit later. What I will do now is let's make a filter here and order it descending by the speech speed. As we can see, we have the fastest recording is that with the ID CB13BC whatever, with over 23 characters spoken on 1 second. So that is probably the fastest input we have, or the fastest recording we have. As I'm not satisfied with the model because it's speaking too fast, I would like to remove either the fastest recordings or make them slower in some sort of pre-processing and optimizing the audio. So let's check that CB13 whatever audio file. It should be in the WAVs directory. Let's check CB13BC. CB13BC. Yeah, looks good. And let's output that.
Hoffentlich gefällt dir der Rest der Geschichte besser.
So, as you probably can hear, it may like it a little bit louder. So,
Hoffentlich gefällt dir der Rest der Geschichte besser.
It's fast. It's hard to understand if you're not used to my voice. So, let's make another example. So, 23 characters per second is obviously really too fast, and might be a reason why the model synthesized too fast audio. Let's go a little bit down and let's check, for example, the first recording that has a speech speed with less than 19 characters per second. So that's the ID 52D2, not R2D2, it's 52D2. 52D2 C69 looks good. So, and check this one.
Aber ohne Vitamine kann ich schlecht schlafen.
It's still fast and natural, but it's not too fast. But that's probably my personal opinion. That might differ from person to person. So, but let's say I'm okay with that the speech speed below 19 characters per second is okay for me. So I would like to remove all the files that has a higher speech rate. What I will do now is, let's change this value from no to yes. So that will affect, as we have ordered it by the speech speed, over 500 recordings. And you can imagine deleting over 500 recordings. That hurts. But what should I do? I have recorded them too fast, though that's the price I have to pay for a good sounding model, which is sounding natural and hopefully then not too fast. So I will set this value to yes for all the recordings that have a speech rate higher than 20 characters per second. So, yes. So let's save this as a CSV file again and close it. So what I could do is I could remove over 500 files manually from lines in metadata CSV and from the WAVs directory. But honestly, that doesn't sound like fun, or? So I've written a second Python helper script. Let's go back to my GitHub repo, and it's called remove files from dataset Python. Same process, even if you have cloned the whole repo, or let's open it as raw script and save it in our folder. And let's take a look to that file. So let's adjust the dataset path again. Documents. That should do the job. What this little script, and again it's less than 50 lines of code, so what this simple script will do hopefully is it will create a new subfolder called removed within your dataset directory structure and will create a new CSV file called metadata cleaned CSV, which is the new one with the reduced lines of all recordings where we have set the value to yes. So when we, let's check it, that's this simple line. So if we have set in that CSV file the value from removed from dataset from no to yes, every line with a yes in that column, that's a specific column, will now be removed from the dataset. So from the metadata cleaned CSV and from the WAFs directory. So let's give this one a try. Save it. Python 3. Remove files from dataset. So output's looking good. We get a list of all the recordings that has been marked in our CSV file generated from the first Python helper script. And it's counting 563 recordings has been marked for deletion. So the script has no errors, that's good. So let's check it here. We have now, in addition to the original metadata CSV file, a metadata cleaned CSV. Let's open those files in our editor. Metadata CSV file has, let's scroll down, 8,078 lines. As we removed 500 whatever, it should definitely be less. So you might calculate it yourself. So let's check the metadata cleaned file. Go down to the bottom and we have 7,551. So that's sounding definitely less than the original version, and removal of around 500 files should fit. So that is the cleaned metadata CSV file now, and we have that additional subfolder called _removed with all the, hopefully, let's check the information, 500 whatever files within. Yeah, 573 files are within that directory. So you can use that simple Python script to clean up your data set directory and metadata CSV based on that specific remove from dataset column. If you set it to yes, for whatever reasons, that will be removed from your dataset. And that should work with every dataset which uses that LJ speech file and directory structure. So it's not just the LJ speech dataset by Linda Johnson and Keith Ito, it's more the structure. So if you use a personal private dataset in that structure, you should be good to use these helper scripts. So that's been my my struggling with too fast recordings and the way I try to solve them or to identify the files at first. So if I remove them or I make them technically a little bit slower, I'm going to think about that. But the first step is to understand if your model is sounding too fast. The reason is definitely that there are recordings that are too fast. So to identify the relevant files is the first step. And then it's up to you if you keep them in the dataset or make them technically slower or remove them completely from the dataset. That's up to you. But that's it for today. As always, I hope you find that type of video helpful and hope you enjoyed it. And that's it. I wish you a nice and pleasant rest of the day, and bye.